All right, so the last section of chapter 4 deals with solving equations with fractions. And really, there's not much new introduced in this section. We've already solved all the kinds of equations we're going to solve already in chapter 3, I guess that was, right? We had done that. So the only difference now is you're going to have fractions involved in these equations. But our equation solving steps aren't going to change, right? If you remember what our equation solving steps were, so if we had an equation that had parentheses, the first thing we'd want to do is eliminate the parentheses by distributing, right? So once we had the parentheses gone, then we'd want to combine like terms that are on the same side of the equation. Then once each side was as simple as possible, we'd want to move all constant terms, which are basically numbers, right, to the side that's opposite the variable. And then once we had all the constants on the side opposite the variable, we would just, as our last step, divide by the coefficient of the variable. So those first two steps were what we usually had referred to as preliminary steps because they were only done on one side of the equation at a time, right? Whereas the third and fourth step, they involved doing the same thing to both sides, right? Like step 3 was generally adding or subtracting on both sides of the equation, and step 4 was dividing on both sides of the equation. All right, so we're still going to follow those same steps. The only difference is now we are also involving fractions instead of just integers into our equations, right? So just one little note on eliminating coefficients. If the coefficients are fractions, there's actually two ways that this can be done. This can either be done in two steps by multiplying by the denominator of the fraction and then dividing by the numerator of the fraction. That would be the two-step approach of clearing the coefficient. Or the one-step approach of clearing the coefficient would be to multiply by the, and we've used this phrase before, reciprocal of the coefficient, because then you're doing the two steps in one, right? Instead of multiplying by denominator dividing by the numerator, you're just multiplying by the reciprocal, which ends up being the same thing, right? So these first two examples here, they're just really one-step equations, so we can actually illustrate this two-step versus one-step process for eliminating the coefficient if we want. So with this first one on the left here, I'll use the two-step approach, right? So I'll multiply by the denominator of the fraction and then divide by the numerator of the fraction. So the denominator of the fraction is 6, so the first thing I would do to get rid of that 6 would be to multiply both sides by the 6, right? So then on the left side, it cancels, and I'm just left with 5c. And then on the right side, negative 25 times 6 is negative 150. So that got rid of the denominator, and now I would get rid of the numerator by dividing by it. So divide by 5 on both sides. It cancels over there, and now I'm just left with c equals negative 30. So that would be the two-step approach for clearing the coefficient, if it's the coefficient's a fraction. The one-step approach is probably easier because obviously it's just one step, right? So in this case, negative 7t over 4 equals negative 35. You really have to view that, right? The coefficient in this case is negative 7/4. So the other way to view this equation is to think of it as negative 7/4 t equals negative 35, right? So you're viewing it as the fraction times t. So if the coefficient is negative 7/4, the way to get rid of it is to multiply by the reciprocal of that, which is negative 4/7. So now I've done it in one step. So on the left, the idea is you get the cancellation, right? And a negative times a negative is a positive. So this just becomes t. And then over here, you can also do the cross cancellation if you remember doing this when we multiplied fractions. 35 over 7 is 5, and then you'd have 5 times 4, which is 20. And I had a negative times a negative, so it's going to become a positive. So this is going to be t equals positive 20. So those are the two ways that you can eliminate fraction coefficients. 2 steps, or just 1 step by multiplying by the reciprocal. Now moving on to these next two equations, these don't have coefficients, right? In this case, the y coefficient is just 1 and the t coefficient is just 1. So we're not going to have to do our final step of multiplying by the reciprocal of the coefficient here because there is no coefficient. It's just 1 already. So these are just your addition and subtraction problems, right? So like in this one here on the left, y minus 1/3 equals 4/5. Remember, again, the goal is to isolate the variable. So what's being done to the y? You're subtracting 1/3 from it. So to undo that, you would just want to add 1/3 on both sides, right? So you're adding 1/3 on both sides. And again, the idea is to get the cancellation on the left. And now you're just left with y, so it's isolated. And then on the right now, you do 4/5 plus 1/3. So it's no different than when you would do in equations with integers. The only difference now is you have fractions involved, so it's a little bit more complicated. But I mean, on these problems, you could just use your calculator if you wanted to. I'm not going to, require you to show common denominators and everything. So in this case, the common denominator would have been 15. So you would have been having 12/15 plus 5/15, and you would end up with 17/15. But you could just punch that in the calculator, and that would give you the correct answer. And then in the one on the right, what's being done to the t? You're adding 5/6. So to undo adding 5/6, you would just subtract 5/6. Right? So on the left, you have your cancellation. I'm sorry, on the right, you have your cancellation. And now on the left, you have 1/8 minus 5/6. So the LCD here would have been 24. So you would have had 3/24 minus 20/24 is negative 17/24. So these are just your one-step equations, so they're not too bad at all. Now moving on here, now we have some two-step equations, right? So remember, the general idea in these is you're using step 3 and 4. So step 3 was to get all of the constants on the side opposite the variable. So in this case, here's the variable y, right? The constant that you have on the side with the variable is the negative 2/3. So you want to move that negative 2/3 by adding 2/3 on both sides. So it cancels out from the left, and you've just got 1/4 y equals 1/2 plus 2/3. Again, you get a common denominator, which was 6. This is 3/6 plus 4/6. So this is 7/6. And now you would do that trick about, all right, how do I get rid of the 1/4? Multiply by the reciprocal of that, which is just 4/1, or just 4. So you do that on both sides. On the left, it cancels. You just have 1y, which is really just y. And then on the right, you can do your cross canceling. 2 goes into 6, 3. 2 goes into 4 twice. And then you would have 7 times 2, 14, over 3 times 1, 3. So 14/3. So y is 14/3. Here, similar, right? Two-step equation, but there's not as many fractions in this one, so it's a little bit easier to deal with. I got to get rid of this negative 1 from the side with the a, so I would add 1 on both sides. So I'd have 6a over 7 equals 12. And then again, now I have this fraction coefficient, so I get rid of it by multiplying by the reciprocal, which is 7/6. So I get the cancellation over here on the left. I have a, and then on the right, I can do my cross canceling. 6 goes into itself once and 12 twice. And then I have a equals 2 times 7, which is 14. So a is 14. So those are your two-step equations. And then these final two are just a little bit different because they involve potentially step 1 or 2, right? Now the one on the left is actually kind of interesting here because what you have to really do is you have to think of these two terms here as being like terms, right? Because y over 6 is really the same as 1/6 y. and y over 4 is really the same as 1/4 y. So these are really like terms. So these can actually be combined with a common denominator of 12, and this would be 2/12 y plus 3/12 y, and it would give you 5/12 y. So this is really step 2 in our equation solving process from above. We're combining the like terms here by adding the coefficients. So 1/6 and 1/4 is 5/12. So this is 5/12 y equals -1, and now we're down to our last step. The only thing we have to do is get rid of this coefficient by multiplying by the reciprocal, which is 12/5. So now it gets cancellation, and you just have y, and then over here you have -1 times 12/5. So -1 times anything, it just changes its sign. So it's -12/5. So y is -12/5. And that's it. Y equals -12/5. So that one actually was easier than it looked, because you had to just recognize those as being like terms, right? That's what you want to notice there. So then in this last one, this is the one that has basically, I guess, all 4 steps involved, right? Because we have parentheses, so we need to distribute to get rid of those parentheses. So we'd have 2/3 x, and 2/3 times -2 is -4/3 plus 5/6 equals -1/2. And now what we have is, now we have like terms on the same side. -4/3 and +5/6 are like terms, so we would combine those, and we'd end up with -8/6 plus 5/6, which is -3/6, but that's actually -1/2. So if we had punched that in our calculator, we would have gotten -1/2, and that's equal to -1/2. So now I'm down to my last 2 steps. I got to get rid of this constant from the side with the variable. So I would add 1/2, and then look what happens. You're going to end up with -1/2, +1/2 cancel on the left, but then 2/3 x and -1/2 and +1/2 on the right, yes, they cancel, but you can't just write nothing on the left side of the equation. -1/2 plus 1/2 is really 0. So we have to write something on this side of the equation. It's just 0 though. So 2/3 x equals 0. So we don't change our steps just because we get a 0 there. We just write the 0 on the right side. And now to get rid of this coefficient of 2/3, multiply by the reciprocal of 3/2. So on the left you get the cancellation, which is what you wanted. So we just have x. And then on the right, 0 times anything is 0. So we just end up with x equals 0. And there's our equation. So the key lesson to get out of this one is, if everything cancels on one side of the equation, you still need to write the 0 there, right? You need to hold the place, right? Because an equation always has 2 sides, even if one of the sides happens to be 0. Okay, so then 0 times anything is just 0.